Hi everyone, we will talk about reduced row echelon form in this video. In the last video, we used an example to demonstrate how to use Gauss-Jordan elimination to solve linear equation systems. In the last step, we found the simplest form of the augmented matrix, and its coefficient matrix is called reduced row echelon form. In today's video, we will talk more about how to get the reduced row echelon form via Gauss-Jordan elimination. There are three row operations that can be done to get the solution set. The operations can be simply concluded as swap, multiplying, and adding. Swap means interchange two rows won't change the solution of the linear systems. Let's look at the same example we used in the last video. We swap R1 and R2. The new system remains equivalent to the original system. Multiplying means multiplying a non-zero real number to a row. Here, R1 is multiplied by 1 second to get the new R1, and the new system remains equivalent to the old one. Adding means to update one row by adding another row to it. Here, R3 is updated by adding R1. Still, the new system remains equivalent. Repeat the three-row operations several times, we can finally get the simplest form of the augmented matrix, which has the same solution with the original linear system. Furthermore, we can get the simplest form of the coefficient matrix, which is the reduced row echelon form. This is one example of reduced row echelon form. Actually, the reduced row echelon form may vary in the appearance, but there are some core properties that the reduced row echelon form will follow. The first property is that rows with all zeros are at the bottom of the matrix. Rows with all zeros indicate that the equations represented by those rows can be obtained from the other rows through the three-row operations. The all zero rows are put at the bottom as they are dependent to other rows. The second property is that in each row, the leftmost entry can only be 0 or 1, and we call it pivot if the entry is 1. In this matrix, there are three pivots. The third property is where there is a pivot, all the other entries in the same column are zeros. The last property is that the pivots shift from left to right in a top-down order. In fact, each matrix has a unique reduced row echelon form. You might have a question: what's the point for the reduced row echelon form to have such properties? Please stay tuned and we will discuss this in the next video. Thanks for watching.